Hello everyone, myself Diksha Gupta from MCF SIM IPS TAVV. Today I am going to solve my second internal test paper, and here is the question 1, which says what is a partial pivoting right pivotal condensation algorithm. In Gauss elimination, the element AKK is known as a pivot element. For example, A11, A22, A33 are known as a pivot element. We have two types of pivoting. First is partial pivoting, second is complete pivoting. Here we are going to understand about the partial pivoting. Partial pivoting is the process of selecting the largest element in the magnitude in the column as positive element and interchange the rows and column as well as. We, uh, we are going to understand it with the help of example. In this example, we can see that row 3 has the largest element, that is 9. So we are going to interchange it with the row 1. So we get these matrices, but we should remember the one thing that after interchanging the rows, our solution doesn't affected. Now we are going to understand about the algorithm. In this algorithm, we are using first we used to read the equation from the user. So we are using two for loops. First for loops, we initialize I with 1 up to nth column, and second for loop is initialized with 1 up to n plus 1, and in n plus 1 is initialized the element which is on the equals to side of. Here we are using the equation in the form of matrices from the users. After this, we are here we are after this, in second step, we used to do a pivotal condensation. Means we are checking that a first element should be a greatest element. If it's not, we are going to do that. For this, we are using another for loop initialized with k equals to 1 up to n minus 1 steps of 1 do. In here, we are used to initialize first element as a maximum element in max and k in p, for checking that all remaining elements of the matrices is greater or not. If it's greater, then we will replace maximum element from this from amk, means from this element, otherwise not. For example, we are initialize using another for loop m equals to m initialized with k plus 1 up to n in steps of 1 do. If amk is greater than max, means that that we got another maximum element, means that a first element that we initialized as maximum, which is not greater, so we replace it and initialize amk as a maximum element. And our for loop is end here. After, or if it will check for any it will check up to any iteration, and our for loop will end here. Now we are going to check if our maximum element is smaller than e. If it's true, then this is the ill condition equation. So we can't do anything, we have to stop here. Now, if p equals to k, means that our first element is only a greatest element, so we don't need to do a pivotal condensation, we directly go to the step 3. uh, Now for k equals to now again using another for loop, k equals to initialize q equals k up to n plus 1 in steps of 1 2. Here we are swapping the element. Here we are swapping the elements, and the swapping the elements means we are arranging the largest element at the top. Now our for loop is end here. Here in step 3, we used to make that all the diagonal element in step 3, step 4, and step 5. In step 3, step 4, and step 5, we used to make all the element 0 which are below the diagonal, and our for loop is end here. So this is our pivotal condensation algorithm. Thank you for watching.